Bienvenidos, Ushamdi, and welcome to this HUT8 networking techtorial on MPLS Layer 3 VPNs. This is going to be part of a 7-part Director's Cut series on MPLS L3 VPNs. In our first part, we took a look at setting up the service provider core with Ospf. In the second part, we're going to be looking at the label distribution protocol, again, focusing on that service provider core network. So we're going to get MPLS up and running in the service provider core. We're going to take a look at the MPLS label forwarding information base. We're going to look at the binding or the LIB, the binding database, label information bindings. And we're going to talk a lot about how MPLS functions. Again, this entire series is a thank you to all of you guys who late last year put me over 1 million views. And so I recently stumbled upon the YouTube statistic that shows you the most popular videos over the last 28 days. And the MPLS L3 VPN series I made 4 years ago to this day is still the most popular of all the videos I've done. So let's go ahead and dive in and take a look at LDP, or the Label Distribution Protocol, which is configuring MPLS. Let's refresh real briefly here our network diagram. So again, we're focusing on router 3 PE1, router 4 P1, and router 5 PE2. That's where we're going to be making these LDP configuration changes. So what is MPLS and LDP all about? Well, it's going to allow us to put a shim header, and it's called a shim header. The MPLS label header is because it wedges in between layer 2 and layer 3. And so as you can see, the first 20 bits of these 32 bits, or 4 bytes, are the actual label number. Now, this is one of those things where in my first video series 4 years ago, I kind of slapped my forehead as I was rewatching it. So the first 16 labels, which are labels 0 through 15, those are your reserve labels. If you don't set your label range, the first label that you would see assigned locally when we set everything up is going to be label number 16. So in that first video series 4 years ago, I think at one point I said it was 0 through 15, and then I think I said 0 through 16. So to be clear, it's 0 through 15 are your reserve labels, the first 16, right? 0 counting as 1, up to 15, that gives us 16. And that's where we see these label numbers here. Then we've got our traffic class bits. These are the formerly known as experimental bits, and those are going to be your quality of service bits. And those are bits 20 to 22. We've got the bottom of stack bit, which is only a single bit. It's either on or it's off, and it basically tells you, hey, this is either the last or bottom of the label stack label, or it's not. And then we've got our TTL bits, right, for time to live, because just like IP, MPLS has a time to live value as well. So that's our setup. Here's our diagram of what we're working with. Let's dive back into the command line and let's configure MPLS. And again, remember, I'm not going deep dive into everything. We're kind of walking through things to get everything set up and operational in a little more polished and consolidated or condensed fashion. So what's the first thing that we need to do? Well, we're going to set the MPLS label protocol to LDP. Now you might be asking, hey, wait a second, isn't that the default? It is the default, but it doesn't hurt to be very specific and explicitly set that value. Then we're going to say MPLS LDP router ID. This is critical. We'll see why here shortly. And it's going to be our loopback 0 address. Remember, it's that loopback 0 address that we advertised into Ospf. So all of the service provider core routers see all of the other service provider core routers loopback 0 addresses. So we're going to use those as the LDP router ID. They're going to become the transport address, which TCP is going to use when LDP discovers a neighbor and then sort of flips from a multicast communication paradigm to a TCP paradigm. All right, and then we're going to set the label range. So I'm going to say MPLS label range. Now, the reason I'm setting the label range, you might not do this in a production environment. And chances are, if you're in a very large service provider environment, there's no way you're doing this. But what I'm going to do here for ease of demonstration is I'm going to set the label range from $3,000 to $39.99. meaning that anything between those numbers is going to be originated here or assigned locally by router 3. So that's how router 3 is going to do it. Now, the last step, and again, you can see this is really straightforward. We set the label protocol to LDP. We set the router ID to the loopback address, which we're advertising into Ospf. We specify a label range to make it easier for us to see what's going on with MPLS and LDP. And then the last thing I do is I'm going to put it onto the interface. So interface gig 03, that's the interface that faces, do show IP interface brief, router 4 or the P router. And all I need to do here is say MPLS IP. Now, I could also go in, and you might be saying, well, wait a second, I heard that with Ospf, you could also activate MPLS with Ospf, and we're going to do that on the P router. So this is one way to do it. Again, I want to show you some variability here. So I can say MPLS IP, and now I've got MPLS running on gig 03. So how could I check that? Well, I could say show MPLS interfaces. This is a great command. I could also say show MPLS forwarding table. Now, this is the label forwarding information base, right? Think of this as like the MPLS equivalent to Ceph or the forwarding table with IP. And now you'll notice a couple things here. And this is a great time to have this conversation because we're going to come back to it a few times during this video. Local label. Remember that range we assigned 3,000 to 3,999? Well, take a look at how it's allocating the labels. Here's 3,000, here's 3,001. Who's it allocating the labels for? Well, it's allocating labels for routes that have been learned in the routing table. And you can see here, when router 3 learned about router 4's loopback address, 4444, I assign it a label, a local label. When I learned about the loopback for router 5, I simply incremented that picked the next label, right, out of my label range, 3001. So now I have locally assigned labels. These locally assigned LDP or MPLS labels, if you will, that I have locally assigned, this is what I'm going to be communicating to any LDP neighbors, letting them know that, hey, if you're trying to get to the 4444, and you're coming through me, I need you to push or impose or swap, put my label 3000 and then send it to me. Because when it comes into me with a label of 3000, the local label for the 4444, I'm going to then know what to do with it. And now this is the next part of our conversation because you're looking at this saying, well, wait a second, it says no label there. What does that mean? This is a problem. If you see no label, that means that your label switch path is not fully configured. So no label is bad. That means we've got a problem here. So this is two ways to real quickly check and see, hey, what does my router look like right now that I've got these commands configured? But again, we don't have an LDP neighbor, so we're not really going to see a whole lot. What if I was to say show MPLS IP bindings, right? So here's the lib, the label information database. And you can see for the 4444, right, my local label or the inbound label, if it was coming to me, it would have a label of 3000. That's what we would hope, right? And then we've got 5555. There's our 3001. You can see that we've got some implicit nulls here, and we'll talk about that. Implicit null, it's label value 3, but you're never going to see 3. It's going to say implicit null. And what that means is I would signal, right, for like my loopback address. I'm going to be telling people, hey, if you're sending it to me, I'm going to tell you, pop off the last label so that I get an IP packet, because if it's 3333, that means it's coming to me. I don't want it to show up with an MPLS header. Get that header off of there, pop it off, send me just the IP packet, because again, the 3333, that's coming to me. Remember, if it was going to 4444, who would be a neighbor of mine, router 4, and this traffic came to me through someone else other than router 4, I would be telling them, hey, push label 3000 on there. That's the label I have assigned for that route in my routing table. Now, you would see OSPF routes get labels. You would see EIGRP routes being assigned labels. BGP routes do not get assigned labels. And the reason for that is BGP BGP takes care of his own labels. All right, so that's router number 3, PE1. We've got the base config on here that we need. Now let's go ahead and work our way through our core. So we're going to come over here to router 4 P1, go from user exec to privilege exec into global config, and we're going to run that same series of commands, right? MPLS label protocol, we want to hard code that to LDP. We're going to say MPLS LDP, LDP router ID. We're going to set that to the loopback address. I'm trying to remember the commands I ran earlier. Then we're going to say MPLS label range, and here we're going to set it 4,000 to 4999. That way it's nice and easy to understand. Now remember, I told you there's two ways we can kick off the LDP process. I can do it on the interface on a per interface basis, or I can go into router Ospf and I can say MPLS LDP autoconfig area 0. Excuse me, and that's it. And what that means is that every interface on this router that's in area 0, I'm going to run the LDP process on. Now, before I hit enter here, let me step back real quickly to router 3, and let's go ahead and kick a debug off. I'm going to say debug, and it's MPLS LDP transport, and I think it's events. And so what I want to see here is I want to see the multicast action that's taking place right now. And you can see that I'm sending multicast packets out to 224.0.0.2. That's what LDP does as part of its neighbor discovery, just like EIGRP, just like OSPF. I'm sending out a multicast packet. Hey, anybody out there that's running LDP, that's listening for 224.0.0.2, hey, I want to talk MPLS with you. If you want to talk MPLS with me, let's take it to the next level. Let's do some TCP. So I'll come over here. I'm going to hit enter. And what we're going to see is within about 5 seconds, and you can see it happen pretty quickly there, we had the LDP neighbor come up. Let me step back over here and now take a look at what's going on. We've got all kinds of action. So the LDP hellos are still going, right? But take a look at what's happening now. Now they're kind of targeted, right? So you can see here we've still got hellos, we've still got hellos being sent out multicast, but we're receiving some information on a more targeted basis because it's taken it to the next level. We now have a TCP connection, and let me kill the debug there with a UAll. And if I say show TCP brief, this is a great command, and take a look. I've got an established TCP session between router 3 and router 4, and this is the TCP port number. It's also the UDP port number for LDP. And you can see the lower of the two router IDs, LDP router IDs, that's going to be your server. And you can see the random high port here, right? 29322. That's where the connection was initiated from. 3333 is going to be the server. So now I've got a TCP LDP session set up. Let's finish out here with our other provider edge router. Again, I'm basically going to, let's exit out one level here. We're going to say MPLS label MPLS. And I jumped on the wrong router. I want to get over here onto router 5. So we'll go from user exec to privilege exec to global config, MPLS LDP protocol. Protocol is going to be, and MPLS LDP, MPLS label. MPLS label, trying to remember which order I'm putting things in here, LDP. So MPLS label protocol LDP, MPLS LDP router ID is going to be that loopback address, the all-important loopback 0 that we configured and advertised into OSPF. And then MPLS label range is going to be router 5, so 5,000 to 5,999. Right, make it nice and easy. And again, I'm on the provider edge router here. Do show IP interface brief. And let me jump into interface gig 04, where we're going to say MPLS IP. And what we're going to see happen here is the neighborship has come up. So let's look at everything from router 5's perspective here. So if I was to say show MPLS interfaces, I've got that one interface that's running. What about show MPLS LDP neighbor? And you can see we've got this neighbor information here. And again, you can see the criticality of that LDP identifier, which is that loopback address. It has to be reachable. We have to have reachability to it. Now, important, this is always confusing output here for learners when they're taking a look at it for the first time. I know it was very confusing for me. So addresses bound to the peer. These are the addresses on router 4, on the peer router, not this router. So these are remote addresses, right? And we should recognize 10344. That's the transit network interface on router 4 that goes to router 3. And then 10454, that's the transit IP address on the interface that comes here to router 5. And then 4444, that's the loopback address. So those are the locally bound addresses. And if we come back to our diagram, you can see 10450/24, there's the .4. Here's the 1034.4, and so those are local addresses on my peer. What other commands do we have? If I wanted to see the parameters, show MPLS LDP parameters, this shows me, most importantly, my discovery, right? Those multicast packets flying around out there every 5 seconds, and the hold time is set to 15 seconds. What if I wanted to confirm my MPLS label range? Right? We should see 5,000 to 599. Now, most importantly, let's take a look now at the show MPLS forwarding table, because now we've got some interesting information to look at here. So let's take a look at the 3333, right? That loopback address over on router 3, who just happens to be, and again, we're on router 5 here, PE2, router 3 is at least 2 hops away. So what do we see here? Well, what we see is when router 5, and I think if I hold control down, or actually, I'm sorry, command, that it's going to limit it to a column. It does not. I think it's option here. Hold on one second. There we go. That's what I wanted. So the local label setup here, right? What does that mean? Well, remember, on router 5, what it means is when router 5 learned about the 3333, he said, okay, I'm going to assign it label 5000. And not only am I going to assign it label 5000, I'm going to tell my LDP neighbors, hey, if you're sending traffic to me trying to get to the 3333, label 5000 is my local label. That's the label I've assigned to it. So you should probably push or swap that on there and get 5000 on there when traffic's coming to me going to 3333. Now the outgoing label. So who is router 5's neighbor? It's router 4, right? It's the only way that router 5 can get to the 3333 is to go through router 4. So here's this outgoing label. Well, if I go to router 4, how did router 5 find out about that? Let's type in and say show MPLS forwarding table. And here it is right here. When router 4 learned about the 3333, it assigned the local label 4000. And then it told its buddies, its neighbors, it said, hey, if you're trying to get to the 3333 and you're coming through me, use or push or swap on label 4000. And so router 5, who is the neighbor of router 4, knows that if I'm sending traffic to the 3333, that's my label switch path right there. It's now complete. I'm going to push or impose label 4000 onto that IP packet going to 3333 and ship it over to router number 4. And now here's where Ceph, and I'm sorry, I pasted that in there. You might be saying, well, okay, so then we don't need Ceph anymore, right? No, just the opposite. Ceph plays a critical role. If I say show IP Ceph for the 3333/32 and I throw a detail on there, take a look at this. So Ceph knows the next hop. It knows the outgoing interface, right? That is Ceph's job in the IP world. But in the MPLS world, it's just as critical because here is label 4000. And then I see my local label as well. But it tells me Ceph is saying, hey, we know that it's going to go out with label 4000 because that is what the label forwarding information base, or the LFIB, which is the MPLS equivalent to Ceph, or the forwarding information database, that's what it's telling us to do, is to get label 4000 on there and then ship it out gig 04 over to over to router 4. Router 4 is going to get that and it's going to inspect it because it knows that packet's coming in as an MPLS packet. It looks at the layer 2 information and sees the ether type on there and says, hey, okay, so label 4000, what do I do when I get something? Because my local label's 4000, something just showed up with label 4000. What do I do with it? Well, I pop the label. Penultimate hop popping. because this is the next to last hop to get to router 3. Remember, we're going to the 3333. So I'm going to take off the MPLS label. I'm going to send a pure IP packet out gig 03 over to router 3. So what if I said show IPsef for the 3333/32 here? And I throw detail on there. You can see I've got this local label, but what's the next hop? Yeah, it's an IP packet. So that's penultimate hop popping right there at its best. All right, well, that is our LDP config. At its most basic, we've now got Ospf configured in the service provider core. We've got LDP configured in the service provider core, and we saw some variability with what we did with LDP. We set it up on an interface, on a per interface basis, and then we threw it into the entire Ospf area, area 0. So the last thing I want to leave you with here is a listing of some important MPLS commands. And these are some of the commands that we used as part of this activity. And I think I've got a couple more there, the label range. And so there we go. And then that show IPsef, right? Very important, because Ceph MPLS will not work if Ceph is not running. All right, well, that is going to wrap up part number 2 of the 7-part series on MPLS Layer 3 VPNs. We've got our Ospf config. We've got our LDP configured. Now we're going to jump into part 3, which is our VRF configuration. Again, thank you so much for watching. Thanks for putting me over 1 million views, and I hope to see you in the next video.